Welcome to my page. My name's Lamek Benson Chibomba Midimo. Okay, today's lesson is based on determining the valence number of an element. So I'm going to open this document here. Okay, now this document, we are going to use it to determine the valence number of an element. Okay, so come up with this one. Okay, I think this is the document which I'm looking at. This is the periodic table. Okay, let me remove this. Okay, I think now it's done. It's removed. So we have the periodic table. Now, while looking at the valence number of an element, okay, so valence number of an element is important, guys, to come up with a chemical formula and a balanced chemical equation. So one cannot write a chemical formula without determining the valence of an element. So that's why now I'm showing you the easiest way to know the valence of an element. So we are going to select some of the elements here. Okay, let me zoom it so that you can see. In group 1, we have lithium, so we're going to tick on lithium. We have sodium and the potassium. Okay, in group 2 we have beryllium, we have magnesium, we have calcium, and we have barium. Okay, in group 3 we can see we have boron, we have aluminium. Then in group 4 we have carbon. Then group 5 we have nitrogen. Then in group 6 I'll pick 2 elements, which is the oxygen and sulfur. In group 7 I'll pick 4 elements. We have fluorine, we have chlorine, we have bromine and the iodine. Okay, then in group 0 I'll pick 4 elements. We have helium, we have neon, we have argon, we have krypton, and we have xenon. Okay, so these are the elements, and between group 2 and group 3 here we have these elements. I'll pick on iron, and I'll pick on copper, I'll pick on zinc, and I'll select the other one, which will be silver. Okay, so what is valence? Valence is the measure of the combining capacity of an element to bond in order to form a stable molecule or a compound. A valence is the measure of the combining capacity of an element to bond in order to form a stable molecule or a compound. Okay, so each element has its own combining capacity, and that is what determines how that element is going to bond, or we call it the combining power. Okay, so let's look at these elements now. We assign the valence numbers. So we have elements in group 1. They have the valence of 1. So I'll write the valence number on top of the periodic table, on top of the group here. So these have the valence of 1. We have lithium, sodium, and potassium. Okay, those in group 2 have the valence of 2. Okay, possibly it's because they lose 2 electrons. So we have beryllium, magnesium, calcium, and the barium. Okay, selecting these are the most common used elements, so I'm picking on this. So in group 3 we have boron and the aluminium. So these have the valence of 3. Then that is in group 3. Okay, in group 4 we have carbon, which has the valence of 4. Okay, then as we move from carbon going to the right side, okay, the valence number begins to decrease. So from 4 it will go to 3, where we have 3, which is the valence of nitrogen. Then the valence of 2 is for oxygen and sulfur. Then the valence of 1 are these 4 elements, which is the fluorine, chlorine, bromine, and iodine. Okay, Then in group 0, we have helium, neon, argon, krypton, and xenon. So we have 0. Okay. Okay. Now let's go through this again so that you master this. Now on the periodic table, we have the two groups that have the same valence. Okay, two groups that have the same valence. We have group 1 and group 7. They have the same valence, and that is the valence of 1. Okay, so here I've just selected a few elements. We have lithium, potassium, and sodium. Okay, lithium, sodium, and potassium in group 1, they have the valence of 1. And also those in group 7, we have fluorine, chlorine, bromine, and iodine, the valence of 1. So guys, you have to master that one. You have to memorize it as many times as possible. So you should just know that elements in group 1 and 7, they have the valence of 1. Okay, let's go in group 2. These elements in group 2 have the valence of 2. Okay, we have beryllium, magnesium, calcium, and barium. Okay, and in group 6, we have oxygen and sulfur. So these have the valence of 2 as well. So group 2 elements and group 6, they have the valence of 2. Okay, now let's go to the next. We have aluminium and boron here. These two elements in group 3, they have the valence of 3. So you just have to master the valence to say, okay, aluminium and the boron, they have the valence of 3. Then in group 4, we just pick carbon, which has the valence of 4. Then in group 5, we have nitrogen, which has the valence of what? 3, where we said that the valence number begins to decrease starting from carbon going to the right side. Okay, where we have nitrogen from 4 to 3. So we can see the decrease in the valence number. Okay, so you just have to master this one. Okay, and we have between group 2 and group 3, we have iron. Iron has 2 valences. We have ion 2 and ion 3. Okay, then copper, we have copper 1 and copper 2. Then zinc, the valence is 2. Then silver, the valence is 1. Okay, so that's how we can master. So iron and copper, these have more than one valence, as you can see. So iron has 2 and 3, copper 1 and 2. So there's copper 1 and copper 2. Zinc, you should always know that it is always 2. And the silver, wherever you find it, just know that its valence is 1. Okay, so why are we looking at the valence number? It's because we're interested in writing chemical formulas. So in an exam, you need to write the chemical formulas as fast as possible. So find a way of mastering this. Memorize it if you can. Sing a song if you can. But don't forget the valence number of an element. No student has ever passed chemistry if they are failing to master the valence number of an element, because the valence number is what they will use to come up with a chemical formula and use those chemical formulas to come up with a balanced chemical equation. Okay, as you know that chemistry is a subject of chemical reactions. We write different reactions from time to time. But if you have mastered the valence number of elements, then you have no problem. Okay, now let's try just 2 examples on how we can write the chemical formula using these valence numbers. Okay, let's say you want to write aluminium oxide. So you have to write the chemical symbols. We have aluminium oxide. Okay, this is aluminium. So you have to figure out what is the valence of aluminium, which is a 3 here, you can see from the periodic table. Okay, so you write 3. Then oxygen has 2, as you can see from here. Then you have to exchange these valences. The 2 comes at the bottom right side of this element, and 3 comes at the bottom right side of this element, which is oxygen. Okay, so you write, so you are going to say aluminium, you write 2, then oxygen, this 3 comes this side. So this is the formula for aluminium oxide. Okay, now let's pick another element. Now what if elements have the same valence? For instance, you are writing copper 2 oxide, so you have to write copper and the oxygen. Okay, then copper has 2, oxygen has 2, so the valences, if they have the same valence, they will cancel each other. Okay, then this one goes to copper here, and this other one here, which has reduced, the 2 has reduced to 1, will go to oxygen. But when the valence has reduced to 1, it means that you don't have to show those numbers, so you just write the chemical formula directly. Okay, like this one. So there is an invisible one here on copper and invisible one on oxygen. So this one is the formula for copper 2 oxide. Okay, so this is how we use the valence number to come up with chemical formulas. So in my next lesson, we'll look at this in details, so that we use the same chemical formulas that we'll come up with to come up with the balanced equation. Okay, so guys, this was my video. So you can like my page, you can send comments, and please follow my page and subscribe, so that we get to interact and learn a lot of things. Okay, thank you so much. Okay.